considered to be non-gravitational acceleration, a subject that could reveal the existence of a propulsion system or some engine to the object.
2025, NASA's deep space feeds light up with an unprecedented discovery, 3I/Atlas, only the third known object from outside our solar system. Insiders leak internal memos, revealing the unimaginable, sharp, geometric patterns deep inside its icy core, flashes of light repeating in patterns too precise for nature, surfaces smoother than any comet ever seen. Panic erupts behind closed doors when a NASA livestream suddenly cuts to black as the object's core glows brighter. What exactly did they see? The official story says comet, but the new 3I/Atlas data is so strange, so engineered, it's sparking a wave of doubt and fear. If this isn't a comet, then what is it? 3I/Atlas entered the record books on July 1st, 2025, when the Atlas telescope in Chile picked up a faint, fast-moving object against the backdrop of distant stars. Astronomers quickly realized what they were seeing wasn't just another comet. Its orbit doesn't loop around the sun like everything born in our solar system. Instead, 3I/Atlas follows a hyperbolic path, one that can only belong to a visitor from interstellar space. This is just the third time humans have caught an object from another star system passing through our neighborhood. The first, Oumuamua, or Mu'ar, was a dim, cigar-shaped mystery. The second, Borisov, looked more like a classic comet, but was smaller and fainter. 3I/Atlas is different. Early estimates from Hubble suggest its nucleus could be as wide as 5.6 kilometers, making it the largest interstellar object ever detected. Even if it's smaller, the sheer brightness and activity as it approaches the Sun have stunned researchers used to more subdued comets. Tracking data shows that 3I/Atlas will make its closest approach to the Sun at about 1.4 astronomical units, just a bit farther out than Earth's orbit, on October the 29th or 30th, 2025. Its nearest pass to Earth will be at 1.8 AU, putting it well beyond the reach of any spacecraft scramble. Once its slingshot's past, gravity will fling it out of the solar system forever. There will be no second chance. The urgency is real. Every major observatory, from the James Webb Space Telescope to ground-based arrays, is racing to capture images and spectra before 3I/Atlas vanishes for good. The object's coma, its halo of gas and dust, was already active when it was still 6 times farther from the Sun than Jupiter, a level of volatility that's rare even among solar system comets. For scientists, this is a once-in-a-lifetime opportunity. The data gathered in these few months could rewrite what we know about the chemistry and origins of interstellar wanderers, but with a path that never repeats and a speed that defies easy pursuit, missing a single observation window could mean losing answers forever. Whispers of internal NASA memos began circulating on encrypted forums and private chat groups in mid-August. The language, stripped of technical jargon, was blunt. One document described angular, lattice-like formations glimpsed within the dense carbon dioxide shroud, shapes that defied the chaotic, irregular structure expected from a comet nucleus. Another memo referenced periodic flashes, bursts of light, each spaced by exactly 3.7 seconds, repeating with machine-like precision. These weren't random outgassing events. The signals appeared too regular, too clean, as if following a deliberate pattern. Anonymous sources, never named, always routed through layers of digital obfuscation, claimed the internal Slack channels at JPL lit up with urgent questions. Reflectivity spikes off the charts, read one message. Surface returns smoother than any natural regolith, said another. The implication was clear. Something inside 3I/ATLAS was bouncing back sunlight with a uniformity that no known cometary material could match. Engineers debated whether the Webb and Hubble spectrographs were miscalibrated, but the numbers held steady across multiple instruments and observation windows. No one on the outside could verify the authenticity of these leaks. Yet the specifics, down to the hexadecimal timestamps and the clipped bureaucratic phrasing, felt eerily plausible. The details seeped into late-night Reddit threads and encrypted Discord servers, fueling a wave of speculation. Was the nucleus hiding a geometric framework? Were the flashes some kind of encoded transmission? Or was this all a case of digital pareidolia, scientists seeing patterns in the noise? Against a backdrop of mounting uncertainty, one fact remained unchallenged. The official NASA feeds would soon show the world's best look at the object's core. But just as the anticipation peaked, something happened to the broadcast, an interruption that would send the rumor mill into overdrive. On August 14, 2025, the official NASA livestream tracking 3I/Atlas drew thousands of viewers as the object approached its closest point to the Sun. At precisely 21:34 and 19 seconds UTC, the feed froze. For 17 seconds, the screen showed nothing but static. When the broadcast resumed, the nucleus region of 3Pi/Atlas appeared unchanged, but the moment had already triggered a wave of suspicion. Amateur astronomers around the world, many running their own telescopes and independent streams, compared timestamps. Their recordings showed an uninterrupted view, no blackout, no missing frames. But in the final seconds before NASA's feed dropped, a sudden spike in brightness flared from the nucleus area. The timing was exact. The NASA stream cut out just as the object's core reached maximum intensity. Technical explanations followed. NASA's public affairs account posted that a routine signal loss caused the interruption. Engineers cited everything from bandwidth limits to solar interference, yet the incident's precision, down to the second, didn't sit right with observers. Why would a technical glitch strike at the exact instant of a visual anomaly? And why did independent feeds, relayed through different networks, keep running without a hitch? Online forums dissected the event frame by frame. Some pointed to the lack of an official incident log, others to the absence of any scheduled ground station handover at that time. Theories multiplied. Was the feed cut to prevent the public from seeing something unexpected? Or was it a simple, unlucky coincidence? For many, the blackout became more than a technical hiccup. It was a sign that not all data reaches the public unfiltered, a suspicion that would only grow as the story of 3I/Atlas unfolded. Spectroscopists working with the James Webb Space Telescope turned their attention to 3I/Atlas's coma, hoping for a glimpse of the hidden nucleus. Instead, the data delivered a chemical riddle. Every spectrum returned the same result. Carbon dioxide outnumbered water vapor by 8-1. That's not just rare, it's never been recorded in any comet from our solar system. Typical comets, even those from the distant Oort cloud, show much more water than carbon dioxide. Here, the balance is flipped. Webb's NIR-SPEC instrument captured the signatures on August 6, 2025. The carbon dioxide emission line at 4.26 microns dwarfed the faint trace of water at 2.7 microns. Ground-based telescopes like Gemini confirmed the finding, ruling out calibration error or stray light. The ratio held steady across multiple observations and extraction methods. Adjusting the aperture, background, or coma model barely nudged the numbers. Spectroscopists ran alternative reductions, but the answer never dropped below 4-1, still outside the bounds of any known comet chemistry. This chemical cloak does more than puzzle researchers. It acts like a veil, scattering and absorbing light, making the nucleus all but invisible even to the most sensitive cameras. No direct image of the core has emerged, just a dense, swirling shroud of carbon dioxide. The opacity is so complete that even the Hubble Space Telescope, with its sharpest filters, can't penetrate the gas. The core remains hidden, shielded by a layer that seems engineered to resist scrutiny. Is this the result of exotic interstellar chemistry, or something more deliberate? The possibility hangs in the air. A camouflage so effective it could mask structure, activity, or even technology beneath a cover of gas. For now, the only certainty is that 3I/Atlas is not playing by the rules of any comet seen before. NASA's public image is built on transparency, but the record tells a different story. In July 2016, the International Space Station's high-definition feed cut to a blue screen just as a bright object drifted into view. The official explanation, signal dropout during a routine ground station handover, matched the logs, but the timing fueled endless debate online. That wasn't the first time. Over the past decade, viewers have catalogued dozens of ISS feed interruptions, many coinciding with odd flashes or unidentified shapes crossing the frame. Each time, NASA points to technical causes, orbital geometry, bandwidth limits, or scheduled maintenance. On Mars, the story repeats. Curiosity and Perseverance have both had image gaps that set off speculation. When strange rocks or unexplained glints appeared in raw thumbnails, full-resolution frames sometimes took hours or days to appear in the public archive. NASA's engineers cite bandwidth priorities and relay schedules, and every delayed photo eventually surfaces, complete with metadata and technical notes. Still, the pattern remains. Even Hubble has its share of rumors. Bright streaks and missing segments in images are chalked up to cosmic rays hitting the detector. The raw files are posted for anyone to see, but processed versions often clean away the artifacts. To outsiders, it can look like selective editing. Each incident on its own has a technical answer, but the accumulation of unexplained gaps and delayed releases has left a mark. When the 3i/Atlas feed cut out at the moment of peak interest, it didn't just spark new questions, it slotted perfectly into a long-running pattern. The silence, routine or not, always arrives when the story gets interesting. Harvard astrophysicist Avi Loeb steps into the spotlight with a challenge. What if 3i/Atlas is not a comet at all, but a probe, an artifact designed by another civilization to scan our solar system? Loeb's earlier work on Oumuamua set the stage, arguing that unexplained acceleration and strange light curves could mean engineered origins. Now, with Atlas, the debate intensifies. Loeb's recent white paper, circulated among colleagues, points to the object's smooth reflectivity and the precision of its observed flashes. He calls for open-minded scrutiny, warning against dismissing the artificial hypothesis too quickly. On the opposite side, Neil deGrasse Tyson urges caution. In a primetime interview, Tyson reminds viewers that extraordinary claims require extraordinary evidence. He points to the lack of any direct signal, the absence of non-natural materials in spectra, and the fact that nature often surprises us. To Tyson, Atlas is a cosmic oddity, remarkable, but not a Roswell event. The scientific community finds itself caught between wonder and skepticism. Loeb's group pushes for SETI scans and targeted observations, arguing that dismissing the probe hypothesis risks missing the most important discovery in human history. Tyson and many others insist the burden of proof remains high. The argument isn't just academic, it reframes how we interpret every anomaly, every unexplained data point. If Atlas is a probe, then cosmic context becomes everything. How old it is, where it came from, and what it might be doing here. Trajectory models trace 3i/Atlas back to the Milky Way's thick disk, a region populated by stars and debris that formed between 7 and 10 billion years ago. This isn't just old by solar system standards. It's older than the Sun, older than Earth, and older than any planet that now orbits our star. The chemical fingerprints, especially the carbon dioxide-rich signature, match what would be expected from a body shaped in those ancient turbulent times, far from the galaxy's younger arms. Astrophysicists ran simulations using data from Hubble, Webb, and Gemini, calculating possible birthplaces and migration paths. Every scenario points to the same conclusion. 3i/Atlas is a relic from an era before our world existed. Michio Kaku, speaking on a late-night news special, put it bluntly. If this object is artificial, then someone built it before the Earth even formed. We're looking at a message, or a machine, older than humanity itself. The realization lands with a mix of awe and dread. For the first time, the debate is no longer just about what Atlas is made of, or whether it's natural or engineered. It's about confronting the possibility that our solar system is only a brief chapter in a much older cosmic story. Within an hour of the NASA livestream blackout, social media platforms erupted. The hashtag #AtlasProbe surged to 85,000 posts per hour, outpacing even major political news. Trending alongside were #NASAFeedCut and #CoverUp, each amplifying suspicion that something monumental had been hidden from public view. TikTok and YouTube Shorts dissected the missing 17 seconds, racking up 14 million views in just 3 days. Reddit threads ballooned with frame-by-frame analyses and amateur sleuths comparing timestamps, while influencer accounts speculated about hidden signals and government secrets. The story leapt from astronomy forums to mainstream news, where anchors read out viral tweets and debated whether NASA was telling the whole truth. The sheer volume of posts, shares, and reaction videos made it impossible to ignore. For a brief moment, an obscure interstellar visitor outshined every headline on Earth, not because of what scientists saw, but because of what the world believed had been concealed. Inside the Pentagon, the language changed overnight. Cables stamped with the highest security clearances described 3I/Atlas as a potential non-attributable object, a phrase reserved for the most ambiguous threats. Armed services and science committees on Capitol Hill received confidential briefings, each more urgent than the last. Funding requests for interstellar monitoring shot up without public debate, hidden in emergency appropriations lines. Defense officials ordered new protocols for rapid data analysis, rerouting satellite assets to track Atlas's path and chemical output. Staffers whispered about a temporary classification order, placing all technical discussions of the object under national security review. Even routine mission updates vanished from public logs for days at a time. The sense of unease filtered down through every agency involved. For the first time since the Cold War, the possibility of an unknown, possibly artificial visitor from deep space was treated as a matter of strategic defense. Leaked documents blur across the screen, redacted lines, cryptic timestamps, fragments of official seals. Webb telescope images flicker, each frame colder and stranger than the last. The static-laced audio of a NASA control room crackles, then drops to silence. Snapshots of trending hashtags, messages flooding in from every continent, scroll by in a rush. For a moment, the story is everywhere and nowhere, official statements drowned out by rumor, science eclipsed by suspicion. The feed cuts again. The only sound left is a slow, deliberate heartbeat. NASA calls it a comet. Insiders whisper about a machine. The cameras went dark, just as the mystery brightened. If 3I/Atlas is artificial, then somewhere in the dark, someone already knows we're here. 3I/Atlas was discovered on July 1st, 2025, as only the third confirmed interstellar object ever observed by scientists. Internal NASA memos, leaked to the public, describe geometric patterns and repeating flashes deep inside its carbon dioxide-rich veil, features not seen in typical comets. Spectral data from the James Webb Space Telescope revealed an unprecedented carbon dioxide to water ratio of 8:1, completely obscuring the nucleus. During a NASA livestream on August 14th, a 17-second feed cut coincided with a sudden brightening, fueling questions about transparency. Historical records show similar information blackouts with the International Space Station and Mars rover missions. Despite trending hashtags and over 85,000 tweets per hour demanding answers, NASA's official explanation remains limited. Today, the object's origins, whether natural or engineered, are still classified or unexplained. What is clear, 3I/Atlas fits a pattern of anomalies and silence. As the object leaves our solar system, the data and the doubts remain, documented in the files and footage we have, and the ones we do not.
Paulina Luna, along with rapid telescope retasking, exposed a split between official NASA reassurances and heightened institutional vigilance. Despite intensive monitoring, no direct evidence has surfaced to confirm the presence of mini-probes or hostile intent. Key documents, including internal NASA communications and classified government material, remain inaccessible to the public. Today, the scientific consensus holds that 3I/Atlas poses no collision threat, yet substantial questions persist about its origins and chemical anomalies. As Atlas continues its journey past Earth, the debate underscores the limits of current technology and transparency. In the absence of clear answers, one fact stands: interstellar visitors challenge our readiness, and every new object forces humanity to confront what we truly know and what remains just beyond our grasp.